This conference will now be recorded.
Okay, now let's continue. Okay, guys. We were talking about, yesterday we were doing tuple, and there we have discussed about what is tuple and the internal representation of tuple, and we had also discussed the methods which we can apply on tuple, and we had seen how to work with the tuple function or tuple constructor, and we had discussed so many things there. Okay, today we'll continue that. Tuple is immutable. We didn't test that immutability in the yesterday's session. How tuple is immutable, and why we can't modify. We'll see it. And it is heterogeneous. We had discussed yesterday, and then we had seen. But we cannot. It is a fixed in size. We cannot add or we cannot remove elements from tuple. It's not dynamic. Excuse me. And it is an indexed data structure, as discussed. It has indexing in both directions. What is that? It has indexing in what we call positive and negative, directions. We had discussed that yesterday. So that is the what we have discussed in yesterday's session. Let's continue further. Excuse me, guys. And we had discussed all these functions, right? We had discussed all this. What are all these? We had discussed like min, max. Yesterday we have tested all this sorted, and suppose if you want to sort in descending order, you can use this flag here, reverse flag. We had tested the same in list also. Maybe if you want, you can try it in tuple itself. That's your wish. Okay, if you want to try, if you can go with tuple also. So that you can do it. Then next after that is comparison. I had this is applicable only in 2.x, not in 3.x. If you try this in 3.x, this Python 3.x, it won't work. So you can test it in the previous version of Python. It's simple. It returns three values. If both are same, it returns 0. If not, it returns either 1 or -1. Okay. So then what else? Another important point is tuple is immutable. Let's see that. Tuple is immutable. So let me just show you here. So this is a small tuple. Let me get into the Python prompt. Now you take a small tuple 1, 2, 3, 4, 5. Then if I want to extract first element, we can use index here like this, isn't it? And we had also seen yesterday how to iterate tuple. See, 1 minute, guys. There are some local elections going on here, okay, in Telangana. So 1 minute, let me just wait for some. Lot of campaigning is going on. Right, when there is a campaigning, these people will put loud music, and they keep doing this campaigning. But anyhow, let's continue the auto mode on. So this is how you extract it. Suppose if I should modify, if it is list, I can do like this: x of 0 equal to something like this 100. Then when I enter, that one is replaced with 100. If it is list, I am saying. If it is tuple, you only observe that. Can you see there what it is saying? Tuple object does not support item assignment. Means you cannot modify immutable objects. So once you create a tuple, you cannot modify that scalar elements. Following? Then you can ask me what you can modify. Then there is something which we had discussed yesterday. If at all, if the object is what, if it is immutable inside tuple, we can modify that. We'll just try to check it out. Okay, suppose you take an example. Here I am taking a list. Okay, this list is something like 1 comma 2 comma 3. So if you see, is list a mutable object? Yes or no? Is it mutable or immutable? It's mutable, but it is present in tuple. I cannot modify tuple, but I can modify list. Okay, means I cannot modify other elements, but I can modify mutable elements inside tuple. Means inside this list, inside this tuple, I can modify the elements of list, but I cannot modify other elements. I don't have a choice there. How? Let me just show you. You see now, the index of list is 0, 1, 2. So it is 2. Inside that, I want to modify the element in the 0 inside list. Again, list has indexing, right? Again, list has indexing like 0, 1, 2, like that, isn't it? So inside that list, I want to modify 0th element. So now I'm trying to give it as 100. Now let me print x. Can you see there? Can you see that? So the index of list is 2. And again, inside that, the index of elements, each element has an index that you can mention with another index operator. Are you following or not? So now I can modify a mutable object inside a tuple like this, but I cannot modify other immutable objects or scalar objects. Are you following? If it is a mutable, then you can modify it. If it is immutable, you cannot change it. I told you in the beginning also, most of these scalar objects are immutable. Even string, these are all immutable objects. We cannot modify. But list is mutable. We have a very clear discussion from the last 3 sessions. Not one session, sir. We had discussed this from the last 3 sessions that we can modify list, and list is a mutable object. Yes or no? Okay. Now, after this, this is another important point I thought to discuss yesterday. What is that? One, you cannot modify elements of tuple, but if you want to modify, then the objects inside the tuple should be mutable objects. You can modify such objects, but you cannot modify other objects. Do you understand? Next one. Is this points clear, or anybody has any questions on this? Because today I don't have any offline sessions. From now onwards, our sessions are more complete online. Your response matters to me.
It's clear
2 of,
voice.
no, 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 no. 2 of 0 cannot be used. First, you need that Variable, right? If at all if you want to extract anything, you have to use that variable of index. Understood, Vinod? Not possible. First, you should get the index, that list from the tuple. On that list, again, you have to extract element. So, the index of tuple is what? 2. And again, inside that 0 is 1. And again, 1 is 2. And 2 is 3. 2 of 0, it returns 1. 2 of 1, it returns 2. 2 of 2, it returns 3. Are you following, Vinod? So that kind of thing doesn't work, whatever you are trying, because without variable, without reference, you cannot extract anything from these data structures. Following, right? Next one, tuple comprehension. Same like list comprehension, there is something called tuple comprehension. The advantage of tuple comprehension is, some people tell us that Python is simple. We can write 10 lines of code in one line. Some people tell that 100 lines we can write in one line. That is still an exaggeration. But some 5 lines or 10 lines we can convert it to a single line. That's possible. Excuse me. By using this kind of sophisticated techniques like comprehensions, okay, or some other features like this. So what comprehension does, it converts a group of lines into a single line statement. That is the advantage of tuple comprehension. Suppose you have this example. This is a simple example. We have discussed this similar example earlier. Okay, we have this. Now what I am doing in this example, I am iterating 1 to 10, and every time I am finding the power of each element, power of 2 of every element, and appending it to a list. So this list will print powers of 2. The same thing I can implement with this is actually a normal code without any comprehension. So I can do the same with the tuple comprehension. Instead of writing 4 or 5 lines, we can do it in single line. And what is the syntax here? For this is actually, the first one is a list comprehension, the second one is a tuple comprehension. The syntax look like this. The first one is always expression. The second parameter, it takes 3 parameters. First parameter expression, second parameter iteration, iteration means looping, third parameter condition. That's how tuple comprehension. Even list comprehension also has the same syntax. Are you following? List also has a same syntax. Is it clear, right? Point is, what is that? It takes 3 parameters. The first one is expression, second one is iteration, third one is condition. Is it clear? Now, let us rewrite the above program with tuple comprehension. Are you ready for that? Okay. So here, this is your expression logic. That you put it as a first one, first parameter. Here, make it as a first parameter. And the iteration, make it as second parameter. Suppose if you want to apply any filter, make it as third parameter. Now for now, the first program, what we are doing is we are just trying to iterate elements and find the power. That's all. I am not applying any filter. So if you don't apply filter, then you can remove this condition. This is optional, but first two are mandatory. Clear? Okay. So what do you do right now? Just apply your expression and apply your iteration. Iterate from 1 to 10. That's all over. This is tuple comprehension. It returns all the powers of 2 from 1 to 10. Okay, and that is returned in the form of a tuple, and it is initialized to this t here. Following, guys. Now you iterate that t and it will print that. Shall I test it now? You can also test it along with me. So you just take your prompt. You can try from prompt also. That is also fine. So it is not copied. Let me copy one more time. What happened? Usually it gets copied. Okay, I can try from there. Mm, okay, enter. Now this is your T. When I print T, the difference between list and tuple is if it is list, it would have shown the elements, all the powers of 2. But if it is tuple, all that result is written in the form of a generator object. Can you see? There is something called a topic, very important topic in Python, generators and iterators. I'll talk more about this generators and iterators when we go there. Okay. Now, so what is the point now? So how to extract elements then? Then we have to apply iterator. Once you get a generator object, iterate that generator object, and it will return element by element. How simple? Apply a for loop for I in t colon print of I. Excuse me. Got it right? This is how tuple comprehension will work in Python. Following, right? Clear? Suppose if I want to apply a condition, I just want to find powers of only even numbers. Then what can I do? Apply a condition here. What is that? If I percentile 2 equal to 0. Okay, now you iterate it again. For I in t colon print of I. Can you see the output now? If you look at the output, it is just returning only even powers. Following? So means in this way, comprehension reduces the number of lines of code. So one of the very important feature of Python. But it's up to you whether to use comprehension or whether to use normal code. It's up to you. Usually the problem with comprehension is as you are trying to do the most optimization, as you are going for optimizing code, you should have a thorough understanding of coding, because writing code is easy but optimizing code takes expertization. It's not that easy for everyone. Okay, I don't say that it is difficult also, but it comes with practice. Understood? So, but it's one of the very useful and very good feature in Python. Okay, is it clear, guys? Next one. That's about tuple comprehension. I hope you understood this, right? Same thing is there in is there where similar thing is there in list also. List comprehension, instead of that parentheses, you try to use flower braces. Sorry, index square brackets. Then it becomes list comprehension. Following, right? So that's it, guys. Next, we have finished successfully list comprehension. Sorry, tuple comprehension and tuple topic and list topic in collections. Let us see if we have any other pending topics, and then we'll move to the dictionary. I'm seeing dictionary, but before dictionary, if you finish set, that is also fine for us. Okay, let me see if we are having set here anywhere. Yes, we'll finish set first and then we'll switch to dictionary so that it's easy for us. The flow will be correct for us. Set is also one of the very important topic in where in Python. Collections are very core topics. But before going to set, I would like to give one more task to you. Are you ready for the task now, gentlemen?
Yes.
No. Shall we do a small task on tuple before switching to the set? Okay, we'll do one thing. Let's take a small example. And the previous one we have discussed in tuple. Let us see this. See, this was the one I am asking. This example, right? Suppose if we have a data like this in tuple, like where I'll just show you. We have mutable objects inside list, sorry, inside tuple, like this. I'll just show you. Now, what I need is I want you to write a code. This is the example, okay? Already this is implemented. I think we have done it in some other session. So what you do is this is an exam data. You iterate it and extract elements, and you flatten this tuple. What you have to do? What is the requirement? Write a program. Write a program to flatten a tuple. Now, yesterday we had seen flattening array. So what I need now? I need flattening tuple. So how you do is your choice, because I had explained clearly what all different things you can apply on a tuple. Okay, but it's up to you now how to play with it. Is take 2 minutes time and finish it. Okay, then I will explain how to. If you have any doubts, then I will also solve it so that you can observe the outputs. Okay, do it now. Program to flatten a tuple. How do you flatten is your choice. Flatten means merge all the elements into a single tuple or into a single list. I want it into a tuple again. There is a nested tuple there. Means there is what is there? There is a list inside that. Even you can have a tuple inside tuple also. That is also there. Understood? Suppose I might have a tuple also like this. Now you flatten all these elements. Okay, something like 10, 20, and this is a tuple. Now you flatten all this elements from tuple list and okay, and other elements of tuple. Flatten it. Come on. Take 2 minutes, and then we will come and solve it again. So, okay, guys, I'm seeing some of you are able to solve this. That's really good. Let me just give. Let me also solve it because some of our friends understand how it works. It's simple. We have already discussed, a number of times. Same example we had applied on list. Same thing we are trying to apply on tuple. Yesterday also we had a discussion on this. So let us just see this example quickly. So this is the requirement. We need to flatten this. How do you flatten it? See, we can, if see, logic doesn't have any limitation. You can keep on working as many examples as possible. Okay. So I'm just taking it as a test two. Okay. Now, how do you flatten it? First, iterate it for I in x colon. Now, every time when you iterate, check what is this I. So we know apart from that scalar elements 1, 2, 3, 4, there are two types of collections. One is list, the other one is tuple. Okay. Now we have to see, we have to check what is the type of these two, because others we don't need to worry about it. If it is list or if it is tuple, then you need to again iterate those. But for others, you don't need to iterate. Okay. So what you have to do is if type of I, okay, equal to list. Some people I see they keep this list in double quotes. Then it becomes string. But this is a class. Don't keep this list in double quote. Otherwise your comparison fail. You see here, I am not using any quotes to compare the type. Okay, because it is not string, it is a class. So don't put it in quotes. It won't work. Now, if it is list again, we should iterate it. How for j in I colon, you declare some empty list also, because usually whenever we are going with this kind of flattening, you cannot add or remove elements to the tuple. The only choice for us is you declare a list and you add that elements to the list, and if you want you can convert that list to tuple. We had seen that yesterday. Yes or no? Okay, so what do we do right now? So this is what. Okay, now if what we have to do, y dot append of I'm not following any order. If I should follow order, then I have to check again if it is int, if it is list. Again, we have to see that also. If you want same order, if you want to flatten in the same order, then you can do like this again. One more small you can add here. If it is int, then add those elements to the list so that you don't have any mismatch in the order if you want to follow the same order of flattening. So you can just say that y dot append of I. Okay, this is one case. Second case is this. If it is list, again you have to iterate it. I is list, again iterate I, and then append those elements to the list y. So j is your if j becomes a scalar element. Similarly, do the same for tuple also. If it is tuple, then add it to list. Which list? Y. Now you print y. You can see now the flattened tuple. And if you want to convert the list to tuple, you know very well. Again, you can say x equal to tuple of y, and now you print x. Okay. Now you might ask me a question, sir. You told x tuple is immutable. Again, you are reassigning tuple. Yes, I'm not modifying any object inside tuple. When I say x equal to tuple of y, a new object is created and old objects gets removed. Okay. Typo mistake. Yeah. Thank you, Veera. I'll correct it. Okay. Now You run this code. This we have discussed yesterday, or many times we have done such examples. Still there is a typo, no? 1 minute. There is a small error somewhere. Type of I. Type of I equal to list. Let me just run this. List object is not callable. Mhm. So what is the issue? List object is not callable if it isn't. Okay, should I put parenthesis here? One more parenthesis. No, type of I equal. That's correct. For I in X. 1 minute, guys. Yeah, yeah. True, true. There is an error. Yes, yes. This comma in the, you see, code is fine. Here, we cannot add elements without separator. So this is the issue. Thank you. Somebody had given me the fix. Sunday, I think. Sunday, thank you. So let me run this. This time it should work. It's not issue with code here. Condition checks. Probably we missed this comma. I missed, not we. Got it right? Perfect. Sometimes these small things, it takes a lot of time to observe. Clear now? That's it. Used j twice. Nothing, that is a local. Mira, it's a local variable, not an issue. Local variable means the scope of that will be within that loop itself. The other loop doesn't have any idea about the other variable. Okay. So that's about this one, flattening. You can try so many. I can give so many n number of examples. Okay, you try all this. Suppose in this list of elements, if I have any prime numbers, you try to print all that prime numbers. Write a program to print prime numbers. Not now. This is an assignment. Okay, I want to switch to set topic. Write a program to print all prime numbers. You see, in this way, we can create n number of programs, prime numbers from a tuple. Okay, like this you can test for so many kind of stuff, like for perfect numbers, like for Armstrong numbers. You can try so many palindromes. Understood? Right, next one. Let's switch to the another interesting topic. But before that, I will ask you a few quick questions. Let's rewind few things, because sometimes questions is better to understand concept clearly. So I missed somewhere. This is set topic. So now before this, I have few questions to you. So far, when it comes to the collections, I had discussed so many collections. One is bytes, byte array. Okay, but I am going very slowly, folks. Let it take time. Not a problem. Every weekend, 2 hours or 2.5 hours is not an issue for us. Okay, byte array, then list, and then tuple. Okay, all these things. Okay. Now let us just understand the differences now. What is that? All these are what kind of data structures? These are all indexed data structures. What data structures? Indexed data structures. Okay, that is one thing. Second question. Now you tell me which are mutable and which are immutable. Tell me. Tell me mutable objects and immutable objects. What are immutable in the given list of collections so far? Which are immutable? Answers? So bytes, is bytes mutable or immutable? So list is mutable, that is very clear. What are immutable? Even byte array is also. So list is mutable, byte array is mutable. Which are immutable? Bytes, bytes is immutable, and then tuple is immutable. Okay. So byte array are is mutable, folks. Bytes is immutable. You can go and check. We have discussed this. Okay. Next one. Order. Which follows the order? Which doesn't follow? Every data structure follows the order. Which one follows the order? All data structures, because all are indexed data structures. When a data structure is indexed, every data structure follows the order. Okay. Next one. What else we can see? Does it allows duplicates? Yes, all these data structures allows duplicates. Okay. Insertion order is preserved. Already we had discussed. Which are dynamic data structures here? Which are dynamic? Tell me, which are dynamic? Means you can add and remove elements from that. Only list is dynamic. Yes, exactly. Remaining all are, they are fixed in size. If it might be bytes, or it might be byte array, it might be tuple. Okay. Can we apply slicing on all this? Is it possible? What about slicing? Yes, no. Give me any one answer. You can type in chat. Okay. Can we apply slicing on all this? Yes, very good. Right, slicing is most easiest and effective approach of extracting sublist substrings. I forget to add string here. The string is also a collection only, because group of characters, and it is also indexed data structure. Okay, so this is basic analysis. Okay, still we can work on. I'll give a small list of programs to solve it. Okay, you try to work on all those samples. If you really work, if you can really work, might be you see a different person in you if you are working on those examples. Set next. I'm moving to the next topic. What is set here? Now it's very simple. So far we had dealt with the indexed data structures, but for now, for a change, we are going to work with the non-indexed data structures. These are hierarchical data structures. Set is not indexed. It is they don't have any index here. Okay, they uses hash code to store your elements, whereas the data structures where we have discussed so far, they use index to store your elements. Okay, and there are two types of sets, of course. One is the immutable set, and the other one is mutable. The immutable is frozen set, which is there in Python 1.6, 1.x. But from Python 2.x, so set became mutable. Okay, we can talk about frozen set. That's not something difficult, but it is a limited small topic. Hardly it will take 10 to 15 minutes. But for now, our concentration is on set. It's not on frozen set. Okay. Now, what about the features of set? How set works? First thing, set is not an indexed data structure. Set is a not indexed data structure. When a data structure is not indexed, your order of elements is not preserved. Your insertion order is not preserved. Okay. So only indexed data structures preserves insertion order. Understood? So set is not indexed data structure. It's the next one. So order is not preserved here. Then it doesn't allow duplicates. You cannot have duplicates in set. You can have duplicates in all other data structures like bytes, byte array, list and tuple. But here you cannot put that duplicates. But if you try to add duplicates, nothing happens. It will just remove duplicates, that's all. And it supports heterogeneous data. Means you can have different types of data inside a set, same like list or tuple. And also there is no slicing. Slicing is applicable only if data structure is indexed data structure. If it is not indexed, you cannot apply slicing. So there is no concept of slicing here. Don't try to put slice operator and try to extract set. Following. Okay. And also you can do so many mathematical operations here like union, intersection, difference, etc. But that's how set is. Got clarity now? So what are the important features of set? It's not indexed like list or tuple or any other previous data structures. It uses hash code to store elements so that insertion order is not preserved here. Order of elements is not preserved. We don't know. We add some elements into set, and when we display, we cannot expect the order of elements to the same. Okay, we might add it in some other order. The output might be in some other order. Don't expect the same. If it is same also, don't worry. It is trying to arrange elements according to some hash code internally. Hash code means it's a kind of address of your element or object. That's what hash code is. Okay. So that is the point. And there is no duplicates also. Don't apply slicing. Now moving to the set introduction. How can we create set? See, any of these collections we can create in two ways, either by using an operator or by using a function or a constructor. If it is a list, we use index operator. If it is tuple, we use parenthesis. If it is bytes, we use what is that? Bytes itself, bytes function. There is no operator for bytes. For byte array itself. If it is set, we can create it in two ways. One is a flower processor, and the second one is what is that? What is the second one? Set constructor. You can see there are two ways here. If you try to put elements in flower processor, it is a set. Okay. And if it is list, we use this parenthesis, this index operator and list constructor. If it is tuple, parenthesis and tuple constructor. If it is dictionary, it also uses parenthesis and dict function. We'll see when we talk about dictionary. Following? Right. So here, let us just test this. What is that? You can test in idle or you can test it in command prompt. For quick testing, I am preferring which one? Command prompt. Okay, let me import OS. So now you take a small example. Use flower bracers 1, 2, 3, 4, 5 and print X. Okay. Now you check type of X. It is written set. You can see there. Suppose I take another example. I put some duplicate elements. Now I am trying to print it. Now if you see, can you find any duplicate elements here, gentlemen? If it is list, you can see this all elements. But if it is set, it is removing the duplicates without much difficulty. You remember, right? We have done a program to remove duplicate elements from list. Do you remember? We had written a code, customized code. But the easiest way of removing duplicates in list is, what is that? Suppose you have a list like this. Okay, this is list. Now I want to remove duplicates. Just now we have observed clearly, if it is a set here, if you see, and if it has duplicates, it will remove those duplicates and return all the unique elements. Suppose I want to remove from duplicates from list. The easiest way is y equal to set of x. Now if you see, this y is a having all the unique elements after removing duplicates. Now I can convert this, what is that, this unique list to unique elements from set to list. Now you see, I can see here y has, what is that, unique elements. Now the easiest way, see, there is not, you don't have much of this, what is that, customized logic. It's a very simple process. First, pass this duplicate list to set and again convert back that set to list, so that the easiest way of removing duplicates will you have here. You follow this? Understood, right? And these constructors, all these constructors, they help us to convert one data structure to another data structure. You can pass a list to set or dictionary to set or tuple to set or bytes to set, and similarly we can do the same for remaining all collections. Okay, are you following, folks? Okay, now that's the idea about set. Now so the way, how do you create set? It is, you can create in two ways, either by using flower braces or by using set function or set constructor. You can call it as constructor. But if you ask me a question why it's called constructor, you wait for some time. When I teach you object oriented programming, then you understand that. Okay, it's a long way to go there. Following now? Now these are all different examples, like parenthesis represents tuple, this flower, this index operator, the square brackets represents list, flower bracers dictionary, and also set. So default will test it. Suppose if it is default, suppose I am creating an empty set now. See here. Okay, now I have something like this x equal. What is this? Is it a set or dictionary? For that you can just by default this is dictionary. Okay. Suppose if I add elements like this 1, 2, 3 scalar elements, then this becomes a set. Until you add elements like this, it is not set. It by default it is dictionary. Okay. You should have to understand this difference also. Clear? Next after that. So we have seen all the different examples so far. Now you got clarity, right? Converting one one collection to another collection. How do you do that? Hope you understand that. Now what methods do we have in set? What methods do we have in set? Simple. Add method, which is used to add element to a set. Update, like extended. It is used to merge one set to another set. Okay, update it seems like okay. We'll just check update like how it works because I'm giving some note here. We'll see and update that. Next one, clears elements, copy, remove, discard and remove are same, but there are few differences. Remove returns exception, discard doesn't throw any exception. We'll see with the example. Pop as usual. These are all different, very core functions available in set. Shall we quickly test all these functions now? Are you ready? So let's test it. So these are all after doing list and after doing tuple. Working with remaining is not something difficult here. It's so simple. Okay, let's start working on them. So now you do it. Add function, what it does. Add an element to a set. It's so simple, right? You create a set and just add something. It will keep adding. Already I have a set here. X dot add of some 20. X dot add of like append. Okay, 30. And then like this. Can you see that? That's how add is. Then update. What update does? It is similar to extending. We have used extended function, right? You remember in list to merge one list to another list. Let's try the same for set and see how it works. X dot update of it takes iterable object. Okay, what it takes an iterable. Iterable in sense it can be a list or it can be tuple or it can be set itself. Okay, you have to give elements like this, something like let me just see, like anyhow duplicates it will avoid duplicates. Give some other unique element, something like 7 8 and 9. Let me try this and print x. Can you see that? So you are merging one set with another set. Similarly, this can be a list also. It has to be any iterable object whenever you are applying update. So some 70 80 90. See, adding duplicates is not going to help much in sets. It's not useful because set anyhow remove duplicates. There is no use of adding duplicates to set. Okay, following or not? So that's it, guys. Next one, that is about update. So whenever we see this kind of functions, they accept an iterable object. Iterable can be not just only set, it can be any kind of collection. Okay, even you can pass a range function and create and pass these elements to the set. You have idea about three forms of range, right? Even range is also a collection. Okay. So next one, clear. There is nothing much to talk about clear. It just you have some confusion. What is your confusion? Tell me, my boy. Tell me, Kotesh, what is your confusion? You can ping me, or you can ask the question. Oh, then you should observe this carefully. Read this set is mutable. Earlier from 1.x there is a set called frozen set. It is not set. What set is that? Frozen set. Okay. If you talk about frozen set, then your question is correct. If you talk about set, it is mutable. Got it? Kotesh. Understood? Right, next. I am somewhere copy. Same actually. Copy means creates a new copy and store it into another reference. Okay. So what copy does? Creates and assign a new set to a reference, new reference. Okay. Y equal to I say x dot copy of that's all copy. Then print y. You get same elements, but x and y are different here. Both are not same objects. You see id of x, id of y. Can you see that? Because copy creates a new object and the address of that object is assigned to the new reference or existing reference. We had discussed this very clearly. And that is what we call what kind of copy is that? It is a deep copy or shallow copy? It is a deep copy. Okay. Somebody is asking me a question. In update set, how the updated value added in between set, like see, it's not like added in between. It will follow some random order. We cannot guarantee in what order it is adding, Sandhya. Because internally set uses hash code. What hash code is there means hash code in sense an address. You are seeing right id of x, that is a hash code. Okay. So based on that hash code, it try to update your set here. So internally, based on that address, it will try to sort elements and store them into the set. And we don't know how it is going to, which algorithm it follows is it's internally in the code, it's in the that update method that has some kind of algorithm which we don't need to worry about that right now. Okay. So next one, copy is done, then remove. What remove does? Just it's very simple, right? Directly it will remove an element from the set. Suppose you have 50, I want to remove 50, just pass 50, that's it. Okay. Suppose I want to remove in other way, I can use discard also. Difference is suppose if 50 doesn't exist, remove function returns exception, whereas discard doesn't throw any exception. Which is best here? The one which throws exception, the one which doesn't throw exception. Which is best? So generally prefer methods or functions which doesn't throw exceptions, because exceptions cause us to break the execution flow. So don't prefer that. Okay. Next one. Clear? Excuse me. So you can test it, sir. These are all simple things. Pop all this. Pop will remove some random element. When I use pop, it pops an element. Usually it will pop a last element, but here which element is removed? It's a random. We'll test all that now. So you see here, this is x. I'm saying x dot remove of 70. Then print this. Okay. Then x dot discard of suppose 70 is not there now. And now when I try to remove something which is not there in the set, it's throwing a key error. What is throwing? It's throwing key error. Suppose you try this with discard, 70 is not there, we know that, but still I am doing it. Do you get any error now? I don't have any error. Okay. Means remove and discard does the same. The difference is remove returns a key error if element is not present, whereas discard doesn't return any error if element is not present. Okay. Both will do the removal. Clear, right? That's it. Next one. After remove and discard pop. x dot pop. Pop removes some random element. It is removing the first starting element again, again. Means it's trying to remove elements from the first in, first out. It's trying to remove something like, of course we cannot guarantee, but the algorithm based on the removal, if you are seeing, it's trying to remove the first element, not the last element. Usually, if it is list, it will follow last in, first out. Means last inserted is removed first. Here it is removing first inserted. It seems like that. Okay. Let me just keep on doing it. Can you see there now? That's it. Clear? So this is how the functions are there in set. Next one after that. So what else? Now we have to go for mathematical functions which is applicable on set. These are simple. The first one, union. Union we have learned it in school days, if you remember. Okay. It is just to simply combine two sets. Just test it, sir. You don't need my help here. Take two sets S1 and S2. When you say union, just combines two elements. You can use union function or you can use this pipe to combine two sets. Test it. And intersection means, union combines all the elements, removing duplicates. Whereas intersection only returns common elements between two sets. You know that, right? First, let's create these two sets. Now add this here. Now S1 of S2. If you want to preserve this result, assign this result to some other variable. Suppose intersection returns common elements. Suppose difference, I think it's minus, I hope. Minus means S1 minus S2. All the common elements which are there in S1 are removed from, are there in S2 are removed from S1. 3, 4 are present in S1, they are removed. Okay, next one. These are all, you have learned this in school days, sir, not now. You can also apply these functions also. Okay. Intersection just returns common elements. Intersection update means it will also update the change in the source in the S1. Suppose if you ask what is that update, I'll just show you here. The difference is after doing these operations, if you print S1, still we get the same old elements. S2, we get the actual original list. Suppose if I do this, update, if you do the update operation, so intersection update, let me just show you. So whatever the change happened, that is updated in S1, not on S2, because S1 is the targeted one here. S1 dot intersection underscore update of S2. Okay. Now print S1. Now you see we are not getting the original list. Once I apply update function, it's modifying. Okay. Earlier, if I don't use update, just the common elements between the two sets are written and still original sets are intact. There is no change to the original sets. But when I say update, then this common elements whichever that is present gets updated into S1, not on S2, not in S2. Okay, you see there, still S2 is same. It has same original elements. So that's how update does. Update updates latest result with the original list. That's what it is. Okay, maybe you can try the same for remaining also. Even for difference update, it also behaves the same. And then symmetric difference. What is symmetric difference? Tell me. What is symmetric difference? Simple, right? You have 1, 2, 3, 4, 3, 4, 5, 6. When we say symmetric difference, it is returning what? It is excluding common elements and returning unique elements. That is symmetric difference. What it is doing? Excluding common elements and returning unique elements. That's all. You can test it, sir. These are all very simple things, not too complicated. Test yourself. I don't need to again test this. Okay. Next one after that. Symmetric difference update. Again, I told you just now. What this update does? This will update the result into the existing original set. Actually, the parent set, source set. Otherwise, that is S1, not on S2. S1 is the targeted one here. This is also called anti-join. Symmetric difference is called as anti-join. Okay. Is subset. Subset means checks whether one set is a subset to another set. What is subset? Suppose S1 is having 1 to 3, S2 is having 1 to 3, 4, 5. Then S1 is a subset of S2 because all elements of S1 are present in S2. That is subset. You can test it. Okay. Next one. You can test it, sir. Next after that. Test it. Don't worry about true false the results. You test and see the outputs. Superset. Superset means what? Now S2 becomes superset to S1. S1 becomes subset to S2. Like that. Okay. Disjoint. S1 is 1, 2, 3. S2 is 3, 4, 5. So means what is disjoint? Disjoint means you can see here 1, 2, 3, 3, 4, 5. What is the disjoint set here? I think there should not be any common elements here, right? Between two sets. Such sets are called disjoint sets. Okay, S1 dot disjoint set of S2 false because there is a common element 3 between S1 and S2 here. You can see here. S2 is not even disjoint to S1. Suppose S2 is 4, 5. Okay. Now S1 is disjoint to S2 because 1, 2, 3 is the S1, 4, 5 is S2, no common elements between these two, so it is disjoint. Okay, that's how it works. So that's all about mathematical functions. That's all about what? Mathematical functions. Is it clear for all of you, gentlemen? Is it clear for all of you? So please test all this and then we'll switch to the next topic. Okay, test it one by one. I'm a bit fast here because these are all simple to understand. Okay, and this document you can download from the GitHub. Okay. Next, are you done, guys? Or should I still wait for some time to test all that? Yes, no, please confirm. Do you want some time or shall I switch to next topic? Okay. Next one. Again, generic functions. You know how to find, try to find len and sum, max, min, all, any. You can test all this again. Okay, x dot, sorry, directly you can take len of x. I don't know what is that. Just one element. That's why it's returning one. Next one, min of x, max of x. Okay, sum of x. Let's try sum. Average of x. I don't know if it is average is there or not. We don't have average. Okay. Okay, these are all aggregate functions. Min, max, average, count. X dot count of. Okay, let me take. X has just only one element. Let us take one new set now. 1, 2, 3. Here count, if you apply count on set, there is no use because every element is unique. There is no repetition of elements. I don't think you have count applicable here, but let me test it out of my curiosity. So it doesn't have any such function like count. Count is applicable for list, tuple, and then bytes. I think you can try for bytes and byte array also, and string also, but not for set because set is not indexed. So there is no point, and also it doesn't allow duplicates. There is no point. Count means every element is a unique occurrence. Okay. Next, what else we can test here? All and any. All means it's like AND operation. If any one element in the set is 0, it returns false. All of x. Suppose if all are non-zeros, it returns true. It's more like doing AND operation. Second thing, any again. If any one element is non-zero, non-zero means it's like OR operation. All is like AND, any is like OR. Suppose if all are zeros here, then only it returns 0. 0, 0, 0, like this. Any of 0. Sorry, any of x, false. Suppose one element is non-zero, then any of x, it returns true. Means it's more like doing OR operation, following, right? That's the idea about functions of a set here. So now we have finished successfully set also. Frozen set is simple. There is nothing much to talk here. But do you get clarity about set now? All of you are good, sir? Yes, sir. Now, clear, right? Next after that, let us finish frozen set also here. So it completes set. Then we might switch to the dictionary. Frozen set, what is this? It is actually the basic version of set, which is introduced in 1.x of collections, Python collections. And this frozen set is immutable. We cannot modify it. Okay, it's like a tuple, more or less like tuple. Tuple in sense, it's just I'm saying that immutability. Talking about immutability means you cannot modify this. Okay, we don't apply other functions like add, remove, same like it's not possible to add elements to this frozen set because it is immutable. And even if you try to add something, remove something, or if you try to do any such kind of modifying operations on frozen set, it returns error, attribute error. See, following, right? Anyhow, this is not that popular right now because from 2.x people are preferring to use set more than frozen set. So only in cases where you don't want to modify elements of a set, and if you want that size of the set to be intact, then you have to go for frozen set. Otherwise, in other cases, it is recommended to go for set itself. It's clear, right? Yes or no? No, yes, no, no. Anybody? Everyone is out of coverage area from here. Gentlemen, clear? Okay, next. Let's switch to the next. This you can test it, sir. The way you create frozen sets is same. Okay, just you can use the constructor frozen set and just pass any iterable object to frozen set that works. Okay, like this, something like this. So simple. Something like x equal to frozen set of 1, 2, 3. We have to pass elements while constructing the frozen set itself. Okay, because it is immutable, we cannot add elements after creating an empty frozen set. It's not possible. Okay, now you can iterate it for I in x colon print of I. Okay, following. So might be you can apply generic functions. If not, you can try. Like, let me just see length of x, min of x. These functions you can apply max of x. Okay, sum of x. Then you can try these examples. Okay, all of x, any of x. Okay, sorted. We are not sure if sorted is applicable for this. Sorted of x. Wow, that is also applicable. Super. Okay, means you can sort elements. Even you can apply sorted on set also. I hope. Okay, the only choice for us, because as we don't have access to hash code directly, the easiest way to sort elements of set is what is that? By applying sorted function. Next one. So you can apply all this, but you cannot say x dot add of some 20 like this 200. This throws error because you cannot modify it, but still you can apply certain operations on that existing set. I have a small doubt here. 1 minute. Two, 1, 3. Of course, nothing to worry. That sorted is returning list there. If you see, it is not returning set. It is not modifying set, converting that to list and doing some sorting on that set and returning that. So that's what I am testing. Okay. If it is a list, there is nothing, problem here. Okay. That's it. So you can apply all these functions directly. These are all common functions. Okay. Might be you might test this. Yeah, index of 1. Let me just try this. Even this is not applicable on frozen set. Why? I think it's my foolishness because I told you clearly, don't try to work with index on set and dictionary. Got it right? If you try to extract something through index, you cannot get it. Okay, because they don't use index, they use hash code. Got it right? That's it, guys. That is the idea about set and frozen set, and the differences you got clarity here, right? Frozen set is immutable and set is immutable. Okay, then I should switch to the next topic. What is our next topic? Dictionary. This set and dictionary are same in many ways, but the difference is means the behavior is same. Both are mutable, both doesn't preserve order, both are heterogeneous, but the behavior is same. What is the behavior? Excuse me, guys. Duplicates are not allowed. In a way, the same concept is applicable for dictionary. But the difference is dictionary is used to store elements in the form of key and value pairs. How elements are stored in the form of what, sir? Key and value pairs. Whereas set doesn't store elements in the form of key and value pairs. It just stores elements in the form of what is that? Normal order. Okay. So here, but dictionary stores elements in the form of key and value pairs. Understood? And again, it's dynamic. Dictionary is dynamic like set. It is growable and shrinkable. You have functions to add a key value pair to a dictionary, and you can have functions to remove key value pair from dictionary. So it's dynamic. But the point is, keys must be unique. Values can be duplicated, no issues. The concept of keys means you cannot have duplicate keys, and if you try to put duplicate keys, the new key replaces old key. Repeating. If you are taking key and value pairs in dictionary, the keys always must be unique, whereas the values can be duplicated. We don't have issue with values. The only point is keys must be unique. And if you try to put duplicate keys, the latest key or the new key replaces the old key. Following? That's it, guys. Okay, next. That's the idea about dictionary. But very useful. One of the most popular and frequently used data structure in Python is dict also. And we can create it in two ways as usual. How do we create it? Either we create with this one, parenthesis, flower braces, or we use a function called dict function, same like a set function, like list function, like tuple function. We use something called, what do we use here, gentlemen? We use something called dict here. Okay. And you create elements like this, okay, in the form of key and value pairs. Can you see here now? So how do we add elements? We add elements like this. I'll just show you a small dictionary here. Let me just show you how to create dictionary. You can parallelly test with me. Some x equal to in flower braces 1 colon, okay, orange, comma 2 colon, apple, comma 3 colon, pineapple, okay, 4 colon, grapes. Can you see that, sir? So this is a dictionary. Every pair is a key value pair. That is one object. Every key value pair is one object here. And this is how we create dictionary, sir. Understood? All of you are clear now? Okay. So we'll do more on this in the next session, sir, because as I'm seeing a little low attendance today, might be a few people might join. It's a very useful topic for many people. Let's see, we'll continue this from, and we'll finish dictionary next week and switch to files. and I'll give you so many assignments. If you can solve all those assignments, then you don't need to look back in Python. You'll be the one of the best developer in Python if you are trying to solve them. Okay, so that's it for today, sir. We'll continue in the next session. These sessions keep going, sir. It won't stop. Then after that, before going to files, I believe I want to work with machine learning algorithms without taking help of existing libraries like NumPy, Pandas, Scikit. First, let's see how the algorithm behaves. Later on, we apply those libraries and see the differences. How simple it is with library and how what exactly the algorithm is without library. Okay, that's it, sir. So that is next agenda. Okay, introduction to the algorithms of machine learning without taking the help of libraries first. Later on, we'll take the help of libraries. Okay, right. Any more questions? Okay. I think I am uploading all the videos today quickly. Somebody is asking me to upload it, but I am not well, actually feeling well. That's why I couldn't do it immediately. But today I'll finish off. Any more questions? Okay. Please share this with your friends, folks, and ask them to attend if possible. Okay. Thank you, guys. We'll meet again next week. Don't miss the sessions. That is what I request you. If possible, bring your friends. That is also helpful for them. Thank you. See you.